Okay. So in the continue with the previous class, we already discussed about different types of wear, as well as how we are going to prevent with the help of mechanical or a lubrication wear. That is what we discussed. And also one important theory we discussed, that is what delamination theory. Okay. So with the same we will continue. We'll go to the next topic called debrace analysis. So it's another important theory which is in the point of where we have to discuss debrace analysis. So this debrace analysis, it is just like a monitoring and controlling the wear mechanism. This analysis is used to monitoring the wear mechanism as well as to analyze the wear mechanism. For that, we are using this debrace analysis. Of course, delamination theory is also with respect to the wear. They have the four important steps, and through that, we are going to prevent and we are going to take the necessary measures to control the wear. Similarly, here one more theory, that is what debrace analysis. This debrace analysis is the continuous trending of wear. It's a continuous trending of wear rate monitors the performance of the machine or a machine components and provide early warning and diagnosis. If we use this debrace analysis in our components or equipments, we can monitor the wear mechanism and also we get the early warning before going to failure. We get the early warning from this analysis and we can correct the whatever the wear or whatever the default is there, we can easily correct those things with the help of this debrace analysis. And oil condition monitoring can sense a danger early than vibration techniques. Means if you use these technique in the oil conditioning monitoring and this sense the a more danger early than when you go with the vibration techniques. Okay, if you go with any vibration techniques to analyze the wear, okay, wear of the component, when compared with that vibration technique, this technique is gives the very early warning or early information so that we can take a measures as possible as early with the help of this theory. And the main objective of this theory, so what is the objective of this theory or this analysis is, first, if you use this analysis in our component, it minimize the component wear. First thing is it will minimize the component wear. That is what the our primary objective. The primary objective is to reduce the or minimize the component wear. Second, it will extend the equipment life. Obviously, if the wear rate reduces, indirectly it will increase the component life. Okay, and ensure lubricant suitability for continued use. Yes, of course, this monitoring or this analysis will provide the whatever the lubricant usage. Okay, if the lubricant is already used and it is having some contaminations, that lubricant has to replace. That information also is given by this technique. And monitor viscosity level for optimum performance. Of course, the viscosity level is very important. By maintaining the proper viscosity level, we can avoid so many types of wears: abrasive wear, corrosion wear, okay, phytic wear. All these wears are depends on the viscosity. If the viscosity reduces, what happens? These wear will takes place. Okay, if the viscosity increases or it will maintain the same viscosity, we can prevent those type of wears. That's why this also provides the viscosity level for the optimum performance, this debrace analysis. And reduce the unscheduled downtime, means whatever the unnecessary time just to monitoring or just to the contact. Okay, so whatever the unwanted time, that time is reduced by this analysis. If we won't use this analysis, then we have to time to time we have to check the viscosity level. Time to time we have to stop the machines and check the viscosity level and check the surfaces. Everything we have to take care. So those time is reduced by using this analysis. And increase reliability, of course, the component life increases. Minimize the wear means indirectly it will increase the reliability of the component and boost the company profile. Obviously it is become more economical and also profit for the company. Okay, so this is what the a simple analysis technique, if we used in our component, we can have these advantages. Clear? So this is what the main objective of this analysis. Why we have to use this analysis? Indirectly, it is profit for the company. If you use that, it is profit for the company. Okay. So the wear particle analysis. If you go with a particle analysis, okay. So there are two types. One is a trending type. That is what quantitative. Okay, it's a quantitative wear. The wear particles concentration to the identify onset abnormal wear. Means here, if you go with this particle wear analysis, okay, this theory is related to the particle wear analysis. The wear particle concentrate the identify the onset abnormal wear. Means is there any abnormal wear taking place between the two surfaces, that it will identify. That is what a trending means. On the surface by naked eye we can analyze. Okay, and the second one particle identification means it's a quantitative. First one is quantity, it is qualitative. Okay, so it is a microscopic analysis. With the help of microscopy we can analyze this. Okay, is there any changes in the grains or changes in the atoms that we can see and we can predict. Okay, if there is any voids, there is a source for crack formation that we can easily see on the surface and we can take the necessary measures to control the wear. So these are the two types. One is the trending and particle identification. Next is the particle identification. Again, the particle classification is there. Particle source, a wear rating, and particle type. So these are the sub steps. If you go with a particle identification, first it will classify the particles. Okay, depends on the grain size. It will classify the particles and particle source. So it will identify the source. Is there any void? It will identify the source. And wear rating means what type of wear is taking place. It will rate the wear and particle type wear mechanism. It will finally go with the wear mechanism. And in the particle classification, either with the ferrous materials, a non-ferrous materials, and contamination. Either we can go with a metal ferrous or a non-ferrous or a contaminant. Contaminants means the foreign particles present in the lubricant. That is also monitored. So particle source. So what are the particle source? Here bearing is the particle source. Okay, bearing surface, gear surface, seal. Okay, interior surfaces, exterior particulates, chemical corrosion, additive ingredients. So these are all a particle source. And wear rating, yes, the wear rating is factor determining the severity. Means it will provide the severity of the wear mechanism. That is depends on the size, shape, composition, and concentration. Okay, so based on these things it will classify or it will determine the severity of the wear. This analysis. And machine wear fingerprint each component wear differently. Means in the machine component different components having a different wear rates. Okay, that is also we monitor with the help of this analysis. And wear modes, we already know that there are wear modes means wear mechanism. There are so many mechanism. Either abrasive mechanism, it is of nearly 50% of the components failure just due to because of this abrasive mechanism, adhesive mechanism, surface fatigue or corrosion fatigue. Okay, it will identify like this step by step. It will identify the a wear mechanism, wear mode, wear particles, and everything it will identify. And this is what the wear mode, and because of first abrasive surface fatigue, adhesive and corrosion fatigue. So these are the main mechanisms, and along with this abrasive there are so many actions. There is a cutting action, flowing action, we already discussed in the earlier class, rubbing action, break-in, blowing, broaching. So these are all so many operations taking place. Broaching means, I think you already studied what is meant by broaching. Broaching, it's a one type of cutting action, only in one direction it takes place, and the cutting teeth are gradually increasing or gradually decreasing, and when it is moving along the specimen it will create the depth of the, either it will create the bruise or it will create the hole. That is what approaching. Okay, so these are all actions taking place under the abrasives. Okay, and the surface fatigue, there is spalling, pitting, brinelling. Okay, so it's just a marks on the surface. Okay, here it will provide the bruise or a holes, and here it will mark or indentations provided. And adhesive means galling or seizing, seize, it will seize the two surfaces. Okay, that is what abrasives. Corrosion fatigue means fritting or cavitations form, it will creates the cavitation or fritting. So these are the modes and there are sub modes. So in the abrasive wear, this is with the help of microscopy, we analyze. Okay, there is a cutting of wear. Okay, in the ferrogram, it's a rubbing, break-in wear. Okay, and cutting wear. So either it is a rubbing, it will form the continuous parallel lines, or there is a cutting wear. Because of hard particle, it will cut the surface. This is what cutting. Okay, and where debris analysis and diagnosis. This monitoring equipment, okay, it's a monitoring equipment. It's a separate monitoring equipment. Okay, and condition and can identify types and possible source of wear and contamination. The main intention is to identify the types of wear. This analysis is used to, just like it is software, analysis software. What is the use of analysis software? I think you already did in your sixth semester. Okay, analysis. What is the use of analysis? It will avoid the time, it will save a lot of time, and also saves a lot of money, because physically we are not going to test the component. But with the help of software, first we create the model and apply the boundary conditions, and we'll check. So what is the stress distribution, what is the deformation, and we are all check everything, and with respect to that we are going to apply the same thing in the physical component. Correct? Here also same thing, debris analysis just like a software or a devices that is used to avoid and predict the way. Clear? And this monitoring equipment condition, first it will identify the type and possible source of wear. Identify the types and possible source of wear and contamination. That is the first function of this analysis. And second, it includes a part count or ferrography. Ferrography, it's a one type. You can see this is a cutting wear on the ferrography. Means we take the SEM image. Okay, so on that SEM image we can see that there is a cutting surfaces or any marks on the surface. That is also a type of wear. Okay, and a particle count identity, all particles present measuring 4 to 100 microns in size. Okay, it will measure the particles in the means in the range of 4 to 100 microns. It means with the small particles also it will count the particles. If particle loss means indirectly it is a wear of the material. Okay, so this is what a debris analysis technique. Technique efficiency, this is a technique efficiency versus wear particle size. If the particle size is 0, okay, 0 micron in terms of micron, okay, it will 100% efficiency, means in the larger particle. If the particle size, see, micron increases means the size of the particle decreases. See, 100,000 microns means it's a very small particle when compared to the 100. 100 micron means it's a somewhat bigger compared to the 1000. If compare 10 micron means it is a greater than 100 micron, like this. Okay. So here if it is 100%, if the grain size is also decreases or increases, the efficiency is also somewhat. When very small tiny particle, efficiency is 0. And here if you go with the ferrography type technique, there are different types. Okay. uh, it is a spectrometric oil analysis, means in the debris analysis again there are so many techniques, and those techniques, if the particle size is bigger, you have to go with this type. It will give the 100% efficiency. If ferrography type, means that is what the with the help of that SEM or TEM analysis, okay, micro analysis, then the particle size is very small. Okay. And here it will provide the 100% efficiency. See here, this technique, second one. And in the third, magnetic chip and related technique. And if further a small particle, if the particle size is very small, then you have to go with third type, and it will provide the 100% efficiency. And very small grain size, we cannot use spectrometric oil technique. Okay. Because it is restricted only up to 10 microns, and second technique restricted only up to 100 or 200 microns. But third technique, it can be 1000 or 2000 microns, we can use these techniques. Means at that level also it provides the effective efficiency for analysis. Okay. And this is what some of the examples where we can use. See here in the first, where debris monitoring methods. The first one, a direct detection of method, a direct detection, and it is a debris sensitive detector is placed. It is placed in the electronic signal processing and display facility. For this, they provided this device is attached. Okay, it is attached and it is connected to the electronics signal processing and display facility. Electronic devices, sensors, and with the display, with the help of the display, we can control. We can control the flow rate, we can control the viscosity, and we can control the contamination. Okay, through this pipe, and this is will supply to the whatever the two surfaces are in contact. On that surface, this lubricant will yes supply. And this type of information is obtained a direct deduction of the amount where debris beginning generated in the machine, means it will uh, again directly connected. It's a direct way of connecting, and it provides the whatever the necessary information for monitoring the wear mechanism. It's a one type. Second type, debris collection method, means the wear debris technique. This is a debris collection and removal from the machine, and cleaning, removal and examination of debris, means it will clean, remove and examine the fluid. It is also one device, it is attached, and it will collect the whatever the necessary data. And lubricant sampling and analysis, it's another type. And debris laboratory analysis, this can use in the debris laboratories we can, it is used. These are the different types we can use in this process monitoring technique. And come to the conclusion, the wear debris monitoring method access the nature of particles generated when components wear, means it will analyze and diagnose the type of wear, type of the particle generated, type of the source of the wear generated, everything it will monitor and control. Okay. First thing, indicates the extra nature of machine problem. It is also indicates extra nature, means if the machine is undergo some vibration or misalignment, if any misalignment or vibration is there, that is also this technique is indicates. And indicates the amount of debris present, means amount of wear is present, it is also displayed. And indicates the size distribution, and indicates the physical form and application of chemical analysis, everything is analyzed by this debris technique. Okay. Clear? In the examination definitely you are going to get a question on this debris analysis. You have to explain what is meant by debris analysis, and explain the objectives and methods, and conclusion you have to explain. Okay. So next come to the last bit of your fifth module is aware testing methods. It is also an important question you may get in the exam. Wear testing methods. There are so many equipments we are using to test the wear rate. So far we discussed only theoretical way of wear analysis and wear theories, but now it is a practical or experimental way of testing the wear rate. So in that there are so many types. One is pin on disc sliding wear. That is you already did in your metal testing lab. Pin on disc. That is what rotating one. In the same way, reciprocating sliding wear. It's another technique. And fatigue wear, thrust washer sliding wear, fluid jet erosion testing methods, gas blast erosion testing, three body absorption, okay, and ASTM P6, it's a one type standard type, wet slurry steel, dry sand rubber wheel, wet sand rubber wheel, and ball catering and scratch testing. Okay, so these are the n number of, there are n number of testing methods. In that we are going to only discuss on the few things. So why we have to go with a requirement of testing methods? Why we have to go? Why we have to use the testing methods? To obtain the fundamental information. First thing is to obtain the fundamental information on the mechanism that occurs in the wear of the material. Why we have to study these technique means just to know the fundamental information on the mechanism that occurs in the wear of the material. Okay, and these studies are normally carried out in the laboratory with a simple test system. Of course, these every test are carried out in the laboratory only. Correct? The testing methods are did in only laboratory with the standard conditions, standard operating conditions. And the characteristics materials performs and determine how variation in the material structure can affect wear and friction. This is already we know that wear and friction is different in the different materials. Okay, if we use different samples, it will provide the different data or different testing results. Correct? If I use steel, it gives a wear rate is different. If I use aluminium, it gives the wear different. Wear rate is different. If I use any alloys, it gives a very different wear rate. So every material having its different wear rate and different characteristics. That is, with the help of these things, we can characterize those properties easily. And to compare with the wear performance and materials using a simple laboratory test and aimed and simulating in service conditions. And this is what the another important thing. At the time of in service also we can test the component and we can provide the necessary data for the smooth operations. And to perform component trials, of course we can provide n number of trials in the laboratory or with the help of these testing equipments. And to perform prototype testing where the new components and are tested in the intended final applications better than controlled conditions in the real application. Means if you want to use the component for the real applications, before going to use that component you have to go with a testing this prototype and we can check, and if we provide for a necessary or a, what better results, then we can use it in the real component. Okay, and these things with this we have to study the different types of wear testing methods. In that, the first important wear testing method is pin on disc. I will say this in your laboratory, in your water testing lab. Okay, this is what the device. The pin on disc, uh, it's a device which consists of a load, it's a measure parameter, and a pin, or it is also called as a holder. It's also called as a holder or pin. And this is a wear disc. This is a disc, standard disc, and here sliding direction, it gives a sliding direction, and the wear track, this is because of the wear track. Okay, it forms. This is a standard testing. And here this device, first this device is with a specimen. First we have to prepare the specimen according to the standards. Okay, according to the ASTM standard, we have to prepare the specimen so that the specimen is easily placed in this folder or in this bin. Okay, and we need a one specimen, testing specimen, along with this uh, disk. This is a disk. Okay, and here we have some parameters like load and speed. Speed and load. Okay, here we can vary the load or we can vary the speed. If you vary the load, it will give the different results. If you vary the speed, it will give the different results. Clear? If you want to increase the wear means, we have to increase the load and speed. If there is no load means there is no wear. If there is no speed or there is no sliding movement means there is no wear. If you provide speed and load, then only it will give the wear. Clear? So these are the equipments, apparatus we need. And how we are going to conduct the test means, first, before conducting, this is a standard disk. It is placed on the device. See here where we are placed here. Okay, and this is a power supply unit, and this is connected with this disk. Once we switch on, the disk will start rotating. Clear? The disk is a very hard particle, hard material. Okay, compared to the specimen. Compared to the specimen, the disk is harder. Clear? Just like a board and choppice. So board is the disk, choppice is the your specimen. Clear? And this disk is connected to the power supply. And here we are applying the load. It's 1 kg, 2 kg, 3 kg, 4 kg. Like this, we are going to apply the load on the specimen. And first, we have to take the specimen, okay, standard specimen, and that specimen before going to place in the pin, we have to check the weight of the specimen or dimension of the specimen. Clear? Either weight of the specimen or dimension of the specimen. So take that specimen in the measuring device and you have to check in terms of gram. If it is specimen is 304 gram. Let us assume the weight of the specimen is 304 grams. It is 304 grams before going to conduct the test. Note on the initial weight. Next, the specimen is placed in the pin. See here, this is the pin. Here we are going to place the specimen and apply the load, and the specimen just touches the disc. It is just touches the disc and we are going to apply the load. The load is standard. If you want, you can take 2 kg as a standard. Take it standard. Okay. And start the machine. Once you start the machine, what happens? The disc will start rotate. Okay. And the disc start rotating and it gives the direction as well as this specimen touches the disc. What happens? There is a surface. Specimen surface is stationary. Disc surface is moving one. So there is a contact between that specimen and the disc, and it is in the relative motion. Clear? So and take time. Okay, for 5 minutes or 10 minutes. Either you can vary the time or you can take time as a constant. And for a 5 minutes with a load of 2 kg and a speed is 500 rpm. Clear? 500 rpm. These are the parameters. If we set 500 rpm, 5 minutes, 2 kg load, and it is contact. Clear? Continuously you will run the operation, and after 5 minutes stop the machine, stop the rotation of the disc and disengage the disc and the pin, the specimen, and take that specimen and again go for weighing of that specimen. If you weigh the specimen, what happens? Yes, whatever the weight, whether the weight increases or decreases. The weight is decreases. Earlier it is 304 kg, sorry, 304 gram. But after conducting the test, the weight of the specimen is maybe 290 grams or 295 grams. That difference of 9 grams or 10 gram, it is of wear of the component, wear rate. And this wear rate, it is only fixed for the 2 kg and 500 rpm and for the 5 minutes. Instead of 2 kg, if I placed 3 kg for the same 5 minutes, for the same 500, what happens? The rate increases. Instead of 295, it may be 285. If I, instead of 500 rpm, if I increase the 1000 rpm, what happens? Again, wear increases. Clear? Like this, we are going to check the wear rate in the component with the help of pin on disc. Clear? And different specimen will provide the different wear rate. Okay? Is it clear? This is a one. See here, this is disc and this is a specimen. This is a pin. It holds that and it is continuously rotating. And because of this, it will forms the circle track because it is rotating one. Clear? Okay. Next type of machine is scratching testing. Okay. So here also it's a standard equipment device and it is also used to test the wear rate and it is also used in the laboratory. Okay, and here it is having an horizontal motor as well as vertical motor just to move this arm, just to move the arm, and this arm is with the indenter. It is with the indenter and the test specimen, see this is a light green, the specimen, it is placed on the table. It is called a friction load cell. Okay, and it is everything is fitted with the table. And here this is a pivoting means like this. Pivoting means one side, both sides are moving. If the load increases, one side will increase the movement. If load increases, another side will move. So that is what pivoting means. It is not fixed one. With respect to the load, that arm or that part will move. That is what pivoting. And this is a pivoting one. Clear? It's a vertical load cell. Okay, and here it's a horizontal load cell, and this is with a specimen and indenter. And here we are going to apply the vertical load. If you increase or apply the load, what happens? This will move upward, and if you move upward means this arm will, what happens? This side will increase the height and this side will apply the load. Clear? So here it will apply the load. If I increase the height here, here it will decrease the height by applying the load, and that is what act on this specimen. Okay, it will make some scratch on this. Clear? So this specimen having a different material means that will hollow scratches, means the depth of the scratch. Okay, the length of the scratch, the dimension of the scratch is depends upon the hardness of the material. That is what indirectly the weight. If the more depth, more scratch means more will be the weight. If it is less means less will be the weight. Okay, and these are the conditions, standard conditions. Testing load up to 100 newtons we can use, and speed 1 mm per minute, means the movement of this is 1 mm per minute, that much of slow speed. Okay, so indenter geometry means that indenter is 0.2 mm radius. Either we can use diamond, just like a hardness test in your material testing lab. Okay, but on that only we are applying the vertical load, but here vertical as well as horizontal both load we are applying. Okay, it is moving vertically as well as horizontally also it is moving. It forms the scratch. Clear? It's the second type of a device. And the third one is two body a ball cratering. It's a two body ball cratering. This is also a one important test. It is used to measure the wear rate. Okay, measure the wear rate, or also these things also used to prepare the specimen. It is also used to prepare the specimen for TEM or SEM analysis. SEM means scanning electromicroscopy, okay, or TEM means traveling electromicroscopy. So for the TEM or SEM analysis, first you have to prepare the specimen. Okay, that preparation is with this type of mechanism, and this mechanism is also used to measure the weight. So here cratering, a ball cratering. Okay, cratering means making the impression, that rotating ball making the impression on the surface. Okay, so here it's a one, see here it's a free ball and the sample and the driving shaft, and here it's a fixed ball, the ball is fixed. Here the ball is a free ball, means with the help of this shaft we can drive the ball. If you want we can move the ball in the right side or left side with the help of shaft, but here it is a fixed ball, is fixed. Okay, and one it's a one horizontal table. Okay, and this is a pivoting time, pivoting, clear, this is a pivoting point, and here I am going to apply the load. Okay, here I am going to apply the load just like a balancer. Okay, if both sides are equal means it is balanced. If one side if I increase the load means another side it will disbalance, correct. The same thing here happens. It's a vertical, it's a horizontal plate on that pivoting point, and one side if I apply the load and here the specimen is there and this is a rotating ball, because of this load what happens, the specimen will moving against to the rotating ball, clear, moving against to the rotating ball, and it will make the crater, on this surface, clear. And this is measured with the help of this equation, v is equal to pi b to the power of 4 64 r, where v is the volume of crater, means because of this rotating ball and because of this weight, whatever the crater impression created on the specimen, that is the volume. If the more volume means more weight, so the specimen is softer. If less volume means less weight, the specimen is harder. Okay, and b is the crater diameter. Okay, and r is the ball radius, this ball radius. With the help of this equation we can find out the whatever the volume of this crater, that we can easily find out. And these are the standard testings, the testing load up to 20 newton, only maximum 20 newton we can apply, not more than that weight. And abrasive, and this is we can use for alumina, silicon carbide, okay, diamond, etc. we can use. Abrasive loading is 10% by volume, a ball size about 25 mm, maximum ball size is 25 mm, and the ball speed is 200 rpm, the rotation of the ball is 200 rpm. Test duration up to 5000 revolutions, means that 5000 revolutions we can take, that we can vary. Okay, by varying the load, by varying the speed, we can change the wear rate, clear. Okay, so these are the some standard wear testing methods or devices that we can use to measure the wear rate. With this I am going to wind up your fifth module, second bit, wear. Okay, and first bit is there, friction. If time permits we will discuss the first bit also. ಅರ್ಥ ಆಯ್ತೇನ್ರಪ್ಪ? So any doubts?